Okay, let's unpack this. We are doing a deep dive into a surprisingly critical and incredibly precise area of medical practice. We're talking about what happens after an instrument like an endoscope has been disinfected. If you think cleaning is the end of the story, well, you are missing a huge part of it, the part that bridges the gap to patient safety.
It's fascinating because the sources you shared with me focus entirely on endoscope drying and storage. It really confirms that the whole goal here, after the cleaning, is to get a scope that is literally completely moisture-free.
So our mission today is really to pull out those essential steps and the very specific timing. That stops a clean scope from becoming, well, a source of infection.
Exactly. Because if there's any residual fluid left, I mean, any at all, especially in those tight internal channels, the whole disinfection process is, completely undermined.
The stakes are just that high, a single drop of water.
It's not just dampness. That tiny bit of water is an instant breeding ground for bacteria. They can form these protective antibiotic-resistant films. So we're not aiming for mostly dry, we're aiming for bone dry.
So, okay, before we even touch the scope itself, let's talk protection. This isn't a casual task. The sources are clear on the need for full PPE, right? Before drying even starts.
Oh, absolutely. The technician has to wear full personal protective equipment. It's about not contaminating the clean scope, but also, protecting yourself from the chemicals it just came out of.
And where does the scope come from?
It comes right out of the high-level disinfection unit, or maybe a storage cabinet if it's being redried. First thing you do is place it onto a clean sheet. That's the starting point for this whole crucial process.
Which brings us to, I think, the first really big number here, the crucial 10-minute rule. 10 minutes, it sounds a little arbitrary, but I'm guessing it's not.
Not at all. It's entirely based on science. Studies have shown, over and over that fluid stays in those complex internal channels, the biopsy channel, air, and water channels, if the drying cycle is less than 10 minutes.
So 10 minutes is the absolute minimum to get them fully dry.
It's the minimum, yeah. It's how long you need to push filtered air through those narrow tubes to really achieve total desiccation. If you don't, any bacteria that survive the disinfection can multiply within hours.
And this 10-minute minimum, it applies to both ways of doing it, manual and automatic.
Both. The duration is what matters, not so much the method. If a unit is doing it manually, which is, it's very labor intensive, they have to blow filtered air through each channel for at least 10 minutes, and they have to time it.
You said filtered air, which makes me think about pressure. Can you just, blast it through there?
No, you can't just blast it, and that's a critical point. The pressure has to strictly follow the manufacturer's instructions for use, the IFU.
Okay, so it's a balancing act.
It is. Too high, and you risk damaging the delicate inside of the endoscope. That's a hugely expensive repair, but if the pressure is too low, you just wasted 10 minutes and left moisture behind. So following that IFU is just as important as the timing.
That makes perfect sense. And I can see why a lot of units would want to go with an automatic method. Can you walk us through how that works, the machine that enforces this rule?
Yeah, the machine basically standardizes the whole process. The tech attaches the air, water, and suction channels to the machine's tubing. It's usually color-coded, pretty straightforward. And this is key. They have to plug the biopsy port. That ensures the air goes where it's supposed to.
And then they just hit a button.
Pretty much. They attach the tubing to the pump and start the cycle. And that machine runs for precisely 10 minutes, forcing controlled, filtered air through all of those internal channels. It takes the human error out of it.
So, okay, we've successfully dried the inside of the scope. The internal channels are desiccated.
Yeah.
Now we move to the outside. And this is where it gets really interesting, I think.
That's right. Phase 2 of getting to that bone dry state. But again, you have to be really careful not to recontaminate the exterior you just worked so hard to clean.
And that's where the specific material comes in. The sources are very, very clear about this. You have to use a lint-free cloth. Why is lint such a problem at this stage?
Because you've just gone through this whole intense chemical and timed process to get rid of microorganisms. Lint is, well, it's foreign matter. It's basically recontaminating the scope. Those little fibers can carry bacteria, or they can just become, food for microbes to grow on. So only a dedicated lint-free cloth.
Okay. Inside dried for 10 minutes, outside dried with a special cloth. Now we're getting it ready for storage. Let's talk about the bits and pieces. What gets attached and what gets left off?
So the general attachments, things for tracking like a label or a tag, those can go on. But the really critical detail here is the valves. None of the removable valves, air, water, suction, any of them, should be attached when that scope goes into storage.
And why leave the valves off? Is that also about moisture?
It's all about moisture, yes. Think about where a valve connects. It's like a little corner joint. Even with air flowing through the main channel, moisture can get trapped right there in that sealed off spot. Leaving the valves off means air can continuously move through those connection points, making sure every last nook and cranny gets dry and stays dry.
Okay, so the scope is dry, it's minimally dressed, no valves. Now for the final step before it goes in the cabinet, the vertical mandate. Tell us about how it has to be positioned.
It has to be hung vertically, straight down. You never ever coil it or lay it flat for storage.
And that's not just for neatness, right? There's a physical reason for it.
It's pure physics. Hanging it straight down without any coils lets gravity do its job. Any tiny microscopic bit of moisture that might still be in there will just naturally drain out or dry up.
So the geometry of how you hang it is just as important as the 10 minutes you spent drying it.
Absolutely. If you coiled it, you'd create little dips where moisture could pool. And that would undo all the work you just did. The vertical hang is like a final insurance policy.
Okay, so the scope is properly dried, correctly hung. Now let's look at the long game. Maintaining that dry state in storage. We're not just talking about a closet here. These are advanced cabinets.
Exactly. This is where technology really helps with the long-term safeguards. These modern storage cabinets are active. They provide continuous air flushing through tubing attached to the scope, even while it's just sitting there.
So it's like a continuation of the drying process.
Sort of. You can think of the 10-minute cycle as the intense blast to get it dry. The cabinet is more like a gentle, continuous dehumidifier just for those internal channels. Air is constantly slowly blowing through them, 247, just to make sure moisture can never, ever settle back in.
So the cabinet is actively keeping it bone dry until the moment it's needed. But even with all that tech, there's still a human check, an administrative policy that have to be followed.
Yes, and this part is absolutely essential. The technology doesn't replace the procedure. Before a scope is ever taken out for a patient, the tech has to do a critical check. They look at the date it was last processed and, crucially, its expiration date.
And what's interesting in the sources is that these dates aren't set nationally or anything. They're set by the individual unit's administration.
Right, and that's important because it puts the accountability right there at the local level. The administration knows their equipment, their environment, their humidity controls. They set a safety window based on all those factors. A place with a basic cabinet might say a scope is good for 7 days. A unit with the high-tech, continuous air flushing cabinets might be able to safely go longer.
So what happens if a tech goes to get a scope and, oops, it's past that date? Is there any gray area there?
Zero gray area. The protocol is immediate and absolute. It must not be used on a patient, period. That date is a hard stop.
So it goes right back to the beginning of the whole process.
Right back to square one. It has to go through a full reprocessing cycle all over again. The manual clean, the high-level disinfection, the full 10-minute drying we just talked about, and then back into storage. An expired date basically means you've lost confidence in its sterility, no matter how it looks.
So when you put it all together, what does this all mean? It's this incredibly detailed choreography. You're balancing strict time, that 10-minute minimum, with specialized equipment, specific materials like that lint-free cloth, and even precise geometry with the vertical hanging.
It really is. Every single step, every minute, it all matters. Because a scope that is only partially dry is, from a scientific perspective, a contaminated scope.
It just highlights that this isn't just about using chemicals. It's a highly technical sequence of events designed to defeat moisture.
Which is the one thing that gives bacteria a foothold. The rigor has to be immense to make sure that instrument is truly safe for the next patient.
It really does. So to sum it all up for you, the 3 things that are totally non-negotiable are 10 minutes of internal channel drying, using a lint-free cloth on the exterior, and storing it vertically without any valves attached.
And, this raises a really interesting final thought. We've seen how critical all this procedural rigor is for patient safety, all dictated by time frames and equipment. But think about that administrative layer for a second. The people in the unit who have to decide on that expiration date, what factors, beyond just time do you think they have to consider? Things like the ambient humidity in their facility, how reliable their HVAC system is, even the potential for human error in just logging the dates correctly. When they put that use by stamp on a scope, that date isn't just a number, it's a reflection of their confidence in every single environmental and human system in their entire unit.